There's tons of transmissions out there nowadays. It seems like they're coming out with them is learn how that system works. It's a big clue. What solenoids does what and when, what kind of solenoid they are, normally high, normally low, open, closed, when is it on, when is it off, is it a pulse width modulator, linear style. Gather all this information so we can understand how the system works. What is the operation in each range? As we all know, different ranges, paddle shifts are down, narrowed the transmission problems and temperature sensor. Those are the big ones that I see cause the most problems. Four-wheel drive switches are up there too, depending on what areas you're in. But speed sensors, range switch, mass airflow, map, AB. You know, if you think you might have a bad map sensor or its readings are incorrect or weird looking, dive in, learn how that map should be operating. Most likely that's going to be your cause of something that looks weird. Might not know how it should work, but it has to be perfect right in the middle of that torque curve, or you're going to get a flare, bind up, something along those lines. We have more complaints of synchronized shifts. You want to stay with the same type of friction material. You know, if you have paper, brown paper come in, you don't want to put a set of high energy frictions in it. When it's a clutch, when one clutch has to release and one clutch has to come on and sync that drum, replace it with the three clutch. Don't replace it with the 5 clutch on the synchronized shift. You will get into trouble. The difference is they apply and they release quicker or harder, and you will feel the difference on a synchronized shift. Programs, reprograms, and clutch adapt or relearns are very important. Especially important on this synchronized shift type. They have to relearn on reverse clutch, and at the same time the 2/4 clutch is starting to come on, and it's going to bring the 2/4 clutch on to complete the shift. Now if you had too tight of a low reverse clutch and it doesn't release fast enough, you're going to get a bump or a bind on the 1-2. Let's say the lower reverse releases too quick, you have too much clearance or a leak in that gasket in the back, one comes off, one goes on, and it has to be timed perfect. Same thing on 3/4. Instead of underdrive, we're releasing the underdrive clutch and applying the 2/4 clutch. That's one reason why, and you're going to find more and more of that in the higher speed units too. Non-synchronized to mine for our 4L60 on the 1-2, and so it is a mechanical timing on that, just because we're all fairly familiar with this unit. Plus this chart has a lot of information on it for us. Let's see, let's just take our 1-2 shift. In first gear, you have your forward clutch, you have your forward sprag, and you have your low roller on. That's what we have for first gear. To make a 1-2 shift, as you see in the chart, all we're doing, the band comes off. Should not say you can't. Most likely if you forward flares up, but very uncommon on a non-synchronized shift. This is the servo. That's your second gear oil. It pushes in on your servo. It applies your band. When it shifts third gear oil, it fills the large area behind the servo in the case there. That's why it's built into the timing of the servo, mostly to do with the E is the 1-2 and the 2-3 is also part of that mechanical. It's good info. It's supposed to operate. Owner's manual sometimes has that information. Also a manual first, you see that the overdrive clutches are applied, first, that kind of thing. If you look at the apply chart, reverse delay, you look in park, low reverse is already applied. So if you have a delayed engagement in reverse from park, most likely you're going to be looking at a reverse clutch input. You're looking at the chart. Now if you have no reverse and we want to test that low reverse clutch, we can put it in manual 1 reverse clutch because we know that portion is not working correctly. Sprag is holding and our low roller is holding. we were told that we had a good third gear. So in third gear, forward, we already know those are good. Forward sprag, we already know. And now we have the 3/4 clutch. So we know the 3/4 clutch is good. So then we know fourth is good also. In fourth gear, it brings on that 2/4 band. So that tells me that band has enough material on it. In fourth gear, the band's good. And that circuit's good for fourth. And in the servo, for second gear oil, that's different than 1-2. To me, we could have maybe a stuck solenoid 1 from on to off. So we know that solenoid cycling. So we know that solenoid's functioning because it makes a 1-3 shift. So solenoid 2 is now crossed off our list of bad parts. It's going to be considered good. And then we have a 3/4 shift. 3/4 shift, we have to turn solenoid 1 off to on. We have a 3/4 shift, so we know that solenoid's good. So we just ruled out both the ability of them. The solenoids are functional. Circuits is where we're going to be looking, most likely the second gear oil circuit. The other common issue is the mechanical side of this, where the band does not apply because the pin's too short, which is a common problem, but we can narrow it down to that. So that just helps us figure out where we need to go when this thing hits the bench, or in this case, pull the servo out, lengthen the servo pin, put it back together, see if you have second gear. So this chart will give you a lot of information.